Okay, so um, there will be exam 4 this week. So I'm going over this practice exam 4. There are 15 questions in this practice exam 4. So first question is, if you randomly select a letter from the phrase, do not run on Chiro, what is the probability that you select vowels? Your answer must be in the form of reduced fraction. You can see that, first of all, you need to find out how many letters are there. So if I count it, do not run on Chiro. So I'm going to write it down here. Do not run on Chiro. And the total letters are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the total is 16. Now I need to find out how many of them are vowels. So vowels means A, E, I, O, U. So these are the letters I'm trying to find. So 1, 2, 3, 4, 5, 6, 7. Let's count one more time. 1, 2, 3, 4, 5, 6, 7. So if we select one letter randomly, then probability of finding vowels is 7 out of 16. So if you try to see here 7 out of 16, this is already in reduced fraction form because there is nothing common factor between 7 and 16. To find out, to go to the reduced fraction, you can also use the calculator. So 7 out of 16 is my answer. Yeah, so that's the right answer. Let's go to problem 2. Problem 2. So problem 2, a group of people were asked if they had run a red light in the last year. 408 said yes, and 265 said no. So if you add these two numbers, you'll get 773. The question is, find the probability that if a person is chosen at random, they have run a red light in the last year. So what is the probability if you choose one of them, if you choose one person randomly from this group, you find the person who, run a red light. So you are trying to find out the probability of yes from this group. So it will be 408 over 773. And you can give your answer as it is, or you can use the calculator and you can put as a decimal answer. That's what the instruction is given here. Give your answer as a fraction or decimal. 408 divided by 773. Wow. Why this is not right? Let me go over that. 408, 265. If I add 408 and 265, that would be 377. So give your answer as a fraction or decimal. It should be the right answer, 408773. I don't know why it's telling me it's a wrong one. If I use a calculator, 408773, I don't have actual calculator, so I'm going to use my calculator on cell phone. 408 plus 265, 408 plus 265, 408 plus 265. It's oh yeah, so my addition was wrong. So it should be 673. Yeah, so sometimes it happens. So you have to make sure that you use your calculator. That's the mistake I did. So I'm going to replace it by 673. Let's submit it. Wow, so my addition was wrong at the beginning. So my answer was wrong because of that. Yeah, sometimes because of the minor mistake, we, might lose the point. So you have to make sure that you use the calculator. Okay. Okay. Problem 3, giving a test to a group of students. The grades and gender are summarized below. So first of all, you have to know how to read this table. These are the grades A, B, C, and then total students, male. This is the row for the males. This is the row for the female, and this is the total. If one student was chosen at random, so out of this 59 total student, we're planning to choose one of them randomly. Find the probability that the student got a C. So for that one, we look here in this column, we can see that there are 26 total students who got C. So C 26. And how many total? You can see that there are 59 total students. So the probability of finding a student with grade C is 26 out of 59. You can use your calculator to have decimal answer or fraction answer. And I'm going to just, put that answer here, 26 out of 59, and submit it. That's the right answer. Okay. Okay, let's go to next problem. Next problem, it's about the die. A die is rolled. Find the probability of the given events. So make sure that before you do this problem, you understand a die means it's a 6-faced, unbiased die. So there are 1, 2, 3, 4, 5, 6 numbers, 1 through 6, and it should be unbiased. This is the die we're talking about. Now the first question is, the number showing is 4. What's the chances of, if you roll a die, you get 4? So you can see that out of the 6 number, there is just only 1 4. So probability of finding 4 is 1 out of 6. So the answer for the first one is 1 out of 6. Second, the number showing is an even number. So out of this 6 number, there are 3 evens, 2, 4, and 6, and there are 3 odd. So probability of finding even is 3 out of 6. You might also say half. Okay. So this is half. And then finally, the number showing is greater than 3. So there are 3 numbers, who are greater than 3. 4, 5, and 6. So again, the probability of, I'm going to use this space, probability of finding a number greater than 3. You can write that statement here, probability of finding a number greater than 3 is equal half. It's half because there are 3 number which are greater than 6, greater than 3, like 4, 5, and 6. So it should be 3 over 6, which is half. So again, the answer for the third one is also half. Let's use them here and submit the answer. Yeah, all of them are right. Let's go to next problem 5. Problem 5. Once again, you have to read this table properly. It's like problem 3. So, but this time you're choosing one student randomly and then find the probability that the student did not get an A. So if you look at this table, you can see that there are 36 students who got A. and there are 83 students in total, and these students B and C, 21 plus 26, they did not get A. So if you add total student who got B and C, that will be 21 plus 26. Use your calculator, and that will be 47. So 47 out of 83, they did not get A. So probability of finding not A is equal to 47 out of 83. You can also do the very same problem differently, but you know, I'm using this approach at this point. 47 out of 83. And that's right. Let's go to problem 6. If you randomly select a card from a well-shuffled standard deck of 52 cards, so to solve this problem, you should know about the cards. If you don't know, then read the notes I have provided in the in the blackboard from this topic. What is the probability that card you select is not a club? So make sure that there are 13 clubs. So there are 52 cards, that's a total. And out of 52, 13 should be club. It should be 13. So, but here we're trying to find out not club. So if out of 52, 13 of them are club, then not club means 52 minus 13, which is 39. So probability of finding a card with not club is 39 over 52. And you can see that the information you have provided here is your answer must be in the form of reduced fraction. If I use the calculator, my reduced fraction for this is 3 out of 4. So the answer should be 3 out of 4. Yes. Let's go to the next problem, 7. A die is rolled twice. What is the probability of showing a 5 in the first roll and even number on the second roll? So for this particular problem, you have to use a probability formula you have given in the notes, which is probability of finding A and B, where A and B are two events. If they are independent of each other, then the formula for these two events is probability of finding A times probability of finding B. You can only use this formula if A and B events are independent, meaning, look at this problem. You have a die, you roll a die, and first time you try to find out probable chances of getting 5, and now again you take the same die and you try to roll second time. So second time, getting any numbers in second time is independent of getting any number in the first time. So we can use this formula to solve this problem. So here the event A is getting a number 5, and event B is getting a number even. So we know that probability of finding 5 is 1 out of 6 because there is just 1, 5. And probability of finding even is 1 out of 2. If you don't know how to do this thing, then you can go back to problem 4 and check this information. Now this A is event A, this 5 is event A, and this even number is event B. So if you want to find out probability of finding 5 on the first round and even number on the second round, we can use this formula, and that would be 1 out of 6 times 1 out of 2, which is 1 out of 12. And just using this formula. So the answer should be 1 out of 12. Let me submit this. Okay. Let's go to the next problem. Where is it? No, I just missed that. Wow. Okay, this is problem 8. Amy buys a bag of cookies that contains 5 chocolate chip cookies, 8 peanut butter cookies, 4 sugar cookies, and 7 oatmeal cookies. So there are 4 different kind of cookies. You can see that chocolate chip 5, peanut butter 8, sugar 4, and oatmeal 7. So altogether, the total cookies in the bag is 5 plus 8 plus 4 plus 7, which is 24. So there are 24 cookies in the bag. Now, you have to make sure that to read the second sentence very carefully here. What is the probability that Amy reaches in the bag and randomly selects a sugar cookies from the bag, eats it, then reaches back in the bag and randomly select a chocolate chip cookies? So we want to find out what is the probability of finding sugar cookies and then finding the chocolate chip cookies. So what is the probability of finding A and B? Here in this particular problem, these two events are not independent, because first time she reaches in the bag, she gets 1 cookies and she eats it. So that means the second event is dependent on the first event. So we have to use the conditional probability formula for that. And if you check your notes, the formula is, if they are dependent, then probability of finding first event and second event is probability of finding the first event, which is probability of finding the sugar cookies, times probability of finding the second event, which is probability of finding the chocolate chip, given that this slash means given that you know she ate chocolate sugar cookies in the first attempt. So that means we know there are how many? 4 sugar cookies out of 24. If you look at the number here, 4 sugar cookies out of 24. So the probability of finding the sugar cookies for the first time is 4 out of 24 times. This one is probability of finding chocolate chip cookies, given that the first time she already ate sugar cookies. So that means if she already ate 1 sugar cookie, the total cookie now, the leftover cookie now would be 23, because 24 minus 1 is 23. So but we also know that there are 5 chocolate chip cookies, so finding one of them is 5 out of 23. So you have to just subtract this 1 from the total, and that's how you can get this number. 4 out of 24 times 5 out of 23. So if you use your calculator for this particular problem, you can I am going to use the calculator. I'm going to just use 4 times 5 is 20 on the top, divide by 24, and again this divide by 23. So my answer is 0.0362. In this particular problem, they are asking me to use either fraction or equate to at least 4 decimal places. So make sure that you round it properly. 0.036, and there is a 2, and after that there is a 3, so I just have to write 2. Submit. Yes. So that's how you do this conditional probability problem. Make sense? Okay, let's go to the next problem. Oh yeah, okay. Next problem is you have a table, and then like problem 4, you have to know how to read the table first, and after that, let me read the question. If one student is chosen at random, find the probability that the student was female and got a A. So you can see that there are, you know, 39 females, and out of 39, only 15 of them got A. So there are 15 females who got A. So if you try to, find out one student randomly, then you can see that there are 71 students. So the total student total is 71, and female with A is 15. So the answer for this particular problem is, what is the probability of finding a female and got A? So there are 15 females with A out of 71. So the answer should be 15 out of 71. Okay? There are 15 females who got A out of 71, so it should be 15 out of 71. Good. Let's go to the next problem, problem 10. Yeah, you can watch this video, one of this video also. This is also about the cards. There are 52 cards, and then you want to find out what is the probability that the card you select is a diamond or 9. So if you check your notes, there is a formula for probability of A or B. This is the formula you need to use. What is the probability, for finding the event A or event B? So here you can see that out of 52 cards, so that total card is 52, and there are total diamond 13, but make sure that out of this 13 diamond, one of them would be 9, right? And then again, the 9s, there are 4 9s, but we already counted 1 here. So the leftover 9 would be 3, because one of the diamond 9 is already here. So altogether, for these two cases, A or B, diamond or 9, there should be altogether 13 plus 3 cards, which is 16. 13 diamond, and one of the diamond is 9. So you already counted 1 9 here, and the leftover 9 are 3. So the total card would be 16. So the chances of getting those 16 card out of 52 is this, 16 out of 52. So, your answer must be in the form of reduced fraction. So if you do that, if you use the calculator, that would be 4 out of 13. Use the calculator, and you can always go from decimal to fraction. Yes. Yeah, again, it's a reading the table thing, but this time it's not, and it's a given. Given means find the probability that a student was female given they got an A. So given means you already know, you are just looking from this A column. So your interest would be not from the total student, but from the A column only. So how many of the students they got A? Male plus female? 17. And how many out of 17, how many of them are female? 10. So to answer this question, you just focus on, if there is a given word, then you just focus on, after that given thing, like given they got an A. So you just focus on A group. So the probability of finding female given that they are coming from A. That's how you write. Probability of finding a female given that they are coming from A. So we know that there are total 17 students who got A. So this number is coming from total students who got A. Out of 17, 10 of them are females. So this is the probability of, getting a female given that they are coming from A group. So that's 10 out of 17. Okay. Okay. So this is the next problem, problem 12, and this is expected value problem. Make sure that to do this problem, you know the formula for finding the expected value. I'm going to use my formula here. The expected value can be found by finding the profit expectation minus loss expectation. So profit expectation means profit times probability of making profit. Loss expectation means loss times probability of the loss. So in this particular problem, I hope you know this formula. If you don't, then use this formula. So now I'm going to find out what is the profit expectation for this particular problem. So profit expectation, and I'm going to use this later, profit expectation is equal to profit for the company. If that product doesn't fail, then the profit would come from that warranty package, which is $20. So if that product doesn't fail, then company makes $20, and the chances of not failing the product is 0.5%. So the profit expectation is profit times chance of not failing the product, which is 0.5%. So it should be 0.005. And loss expectation, let's say that product fails, then they have to pay $150. But make sure that out of that $150, $20 is already from that warranty package. So the company will only lose $130, which is 150 minus 20. So the loss would be $130, and then chances of making that loss is 99.5%, because chances of failing the product is 0.5%. Chances of not failing the product is 99.5%. So not failing means loss. So the chances of oh, okay, I'm sorry about that. That should be here, which is 99.5 should be here, and this should be 0.05, because chances of loss expectation means loss times profit of loss, probability of loss, and the probability of loss is 0.5%. So yeah, so this would be right. So 99.5% is profit probability, and 0.05% is loss probability. Okay, and now expected value, I'm going to use EV for the expected value, comes from subtracting LE from PE. So use the calculator and just subtract this value from this value. If you do that, I'm going to use my calculator. I'm going to multiply 20 times 0.995 minus it's 130 times 0.005, and that is 19.25. So the expected value, and finally the answer should be in dollar, the expected value would be $19.25. So by selling that $20 warranty package, the company could expect $19.25 profit. That should be the expectation. Okay. So yeah, so that's the problem 12. Problem 13, 14, and 15, they are scheduling problem. So let's go here for the 13, 14, and 15. And to do this scheduling problem, first of all, you have to know, the list processing algorithm. If you don't know that, then check the notes I have provided and then try to use the list processing algorithm for this particular problem. So to do any scheduling problem, you just have to copy the priority list first here. T8, T10, T1, T6, T4, T5, 2, 7, 3, 9. So first of all, copy your priority list. And now, if you follow the list processing algorithm, check the diagram here. By checking the diagram, you can see that T1, T2, T3, and T4, they are ready to go. There is no error coming to T1, T2, T3, T4. So if you try to use the list processing algorithm, you just circle the available tasks at the beginning. And they are T1, T2, T3, and T4. So that means this circle means they are available. Now we are trying to schedule the project with 2 processors. So make the schedule P1, P2 processor. And then you can also, give some time frame here. So 5, 10, 15, 20, 25, 30, 35, 40, and you can, keep going as you want. 5, 10, 15, 20, 25, 30, 35, 40, and keep going if you need. So, there's scheduling problems, they are long problems, so you have to make sure that you follow these steps properly. So if you try to go back and look at the list processing algorithm, after you have this circle available tasks, what you do is you assign the first available tasks in order, in the priority list. So you only pick, who is available at the moment, not like T8 and T10, they are not available. So this circle means they are available and you can assign those tasks to the processor. So because T1 comes first, so you assign T1 to the processor 1 and T4 to the processor 2. And for the T1, it takes 3 days. So I'm going to write T1 here. And this is very tiny for me. So it takes 3 days. And for the T4, it takes 11 days, T4. So from here to maybe somewhere here. So on 3rd days, what happens is this T1 will be done. And I will go back to the diagram and I will see if this T1 is done, then by looking this diagram, I can say that T5, is not available, because to make this T5 available, you have to finish T1 and T2 both. But you have not done with the T2. So after done with this T1, there will be no new tasks available. So I have to go back to this priority list and I have to check what is available at the moment. So I can see that in the priority list, T2 is available. So I'm going to assign this T2 to the available processor, which is P1. And then for the T2, it takes 12 days. So T2, 12 plus 3 is 15. Yes. So while, the P1 is busy with T2, the P2 will be done with the T4 on the 11th day. So I'm going to cross this T4 and I'm going to go back here in the diagram and I see if I'm done with the T4, is there any new tax will be available? After done with T4, there will be nothing available. So this available list will be still the same. And then I can see that the next available tax is T3. So I'm going to assign T3 to the processor 2, and which takes 5 days. So T3, 11 plus 5 is 16, so somewhere here. But while processor P2 is busy with T3, the processor P1 will be done with T2. Now if I check my diagram, I can see that T2 is done, T1 is already done, so that makes T5 and T6 both available. So available means I'm going to go back here and circle them, T5 and T6. So now there are two available tasks, T6 and T5, and there is only one available processor at the moment, which is P1. So I'm going to assign the first available task to the processor 1. So T6 takes how many days? 10 days. So I'm going to assign T6 here. 15 plus 10 is 25. While processor P1 is busy with T6, processor P2 will be done with T3. So I'm going to cross this T3 here. So after T3 is done, I can see the diagram here, the T7 will be available. So my available list will be updated. So you can see that in my available list, meaning the circle tags, T5 and T7, both of them are available. But T5 comes first, so I'm going to assign this T5 to this processor P2. And T5 takes 9 days, so 16 plus 9 is 25. So on 25 days, you can see that both T5 and T6, both of them will be done. So if T6 is done and T5 is done, you can check the diagram and you can see that only T9 would be available because T8 is not still available because you need to finish the T7. So only the available task would be T9. But T7 is already available in the list. So we have now two available tasks, T7 and T9. So I'm going to assign T7 to the processor 1. First come, first go. So T7 to the P1 and T9 to the P2. And T9 takes 4 days. So 25 plus 4 is 29. And 7 takes 2 days. So 25 plus 2 is, this is very small, tiny space here. So T7, 2 days, so which is 27. So T7 will be done first. After T7 will be done, T8 will be available. So I'm going to assign T8 to the processor 1, which is 27 days plus 6, which is 33. T8, 33. And then on 29 days, T9 will be done, but still after done with the T9, there is nothing available. So this P2 has to be idle until this 33 days. There is nothing from 29 to 33 because there is no available task to assign for the P2. So I have to make this P2 idle. And then after this P1 is done with T8, after that only, the T10 will be available. So we're going to assign first come to the first available processor, and T10 takes 8 days. So T10 is going to be here. 8 plus 33 is 41. And then still there is nothing available for the P2, so we have to make it idle. So P2 will be idle from 29 days to 41 days. So let's go back and check the available, the given schedule here and try to compare with the schedule we have got here. Okay. The processor 1 will be T1, T2, T6, 7, 8, 10. 1, 2, 6, 7, 8, and where is that? 10. Processor 2 would be T4, T3, T5, T9, and then ideal from 29. Is that? What is that? T4, T3, T5, T9. Let me so let's count. It looks like my number is slightly off. So let me add this number. T4 takes 11 plus T3 5. 11 plus 5 is 16. T5 is 9. 16 plus 9 is 25. Plus T9 is 4. 25 plus 4 is 29. T4, T3, T5, T9. Yeah. So this is the answer. So 29. And you can see that T1, T2, T6, T7, T8, T10. So this is very exactly same with our schedule. So let's submit it. Yes. So as I mentioned you just have to use a list processing algorithm to do scheduling problem. It's very time consuming. So let's go to problem 14. To do this problem, where you are going to repeat the very same process like we did in problem 13, but the only difference is this time you have not given the schedule, but by looking this schedule, you need to find out this information. Like for example, let's say this is the schedule, which is not. I'm not trying to do this problem here at this point, but I'm trying to explain you how to answer this question. For example, let's say this is the schedule for this problem. Then the answer for this would be task 5 is done by, so you can see the task 5 is done by processor 2. So you just select the processor 2 and the starting time would be 16. Make sense? So you can see here in the schedule, task 5 is done by processor 2 and the starting time is 16. So that's how you answer. But first of all, you have to do the scheduling thing. You have to complete the schedule, and from this schedule, you can answer this question. Task 8 is done by, you can see that task 8 is done by processor 1, and then the starting time is, what is that? 27. And then the finishing time of the schedule is 41. But you have to complete this schedule. I'm not going to repeat this thing here. Okay, so if you have any question about this, you can, again, email me or contact me or make an appointment with me. I'm just going to comment about this last problem. For this particular problem, before you schedule the project, you have to make the diagram because diagram is not given here. So after that, it's very similar to the problem 14. So I'm going to help you how to diagram this project using this information. Task 1, 2, 3, there is no task you must complete before you complete the T1, T2, and T3. So you don't need anything to complete. So T1, T2, 3, 3, there is nothing you need to finish before you start the tasks 1, 2, and 3. And now, to start the T4, you have to finish the T1. So there will be arrow going from T1 to T4. For the T5, you have to finish the T3. There will be arrow going from T3 to T5. For the T6, you have to go from T2. There will be arrow from T2 to T6. Meaning is, before you start the T6, you have to complete the T2. Before you start the T4, you have to complete the T1. And you can also write down the time here. And to start the T7, you have to finish the T5. So T7 can be started after finishing T5. To start the T8, you have to finish 4 and 6 both. So there will be 2 arrows coming from 4 and 6. And to start the T9, you have to finish the T6. So T9 will be here, arrow going from here. That's it. So that's your diagram. And you can also add, the end. And that will be like this. So this is the diagram you have to use to solve this problem. Now your priority list is given, and using this priority list and using this diagram and using this time, you can make the schedule with the two processor. And after making the completed schedule like we did for problem 13, you can answer this question. I hope the information I provided here for the practice exam will help you to prepare for the exam 4. Practice this practice test a couple of times, and only after you feel comfortable, you have to take the exam 4. Okay, if you have any other questions, any questions for me, then feel free to email me and make an appointment.